Let's solve this solubility question in general chemistry. It's a very important question. Definitely pop up on one of your tests. Okay, so it says the KSP, which we know means equilibrium when we see KSP or K, of PbI2 is 1.4. Okay, so we have the KSP. How many grams? You gotta remember grams, not moles, grams. Will dissolve in a 1 liter solution of water. Okay, so let's start off by writing the equation. PbI2 will dissociate into, we know it will dissociate into PB2 plus, what do you think it's going to be? It would be 2I minus. Don't forget that there's a 2 here. So let's just say we didn't put down, let's say we do that at the end. So, of course, we know that this crisscrosses. So the 2 goes to the PB and the minus goes to the I. And now when we look at this, we see an imbalanced equation. There's 2 I2s and 1 I2 here on the right side. So again, I just like to, whenever I see a 2 here, for example, or a number right there, I just like to put it in front of the number. So there it is. Okay. And when you see these questions, they always, when you see K, like the capital K or K and KSP, KA, stuff like that, you know it's an ice table. So let's draw our ice table. And like I said, I always like to make a dotted line so I remember what's on each side. Since this is a solid, aqueous, and aqueous, since this is a solid, we know it won't be in the KSP equation, because remember, solids and liquids are not in the KSP. We could just do this, just to remind us. Okay, so since they didn't give us any information on the initial, we know it's 0, 0. And the change is plus x, because of course we're only going to gain, because we don't have, we're like dissociating our ions, therefore we're gaining. And this will be plus 2x, because remember there's a 2 right here. Okay, and the equilibrium will be x and 2x. So when we write our KSP, it's going to be KSP equals to PB2 plus times I minus squared. Remember, we make it squared because of the 2. The coefficient always goes on the exponent in these type of questions. So we'll put that as a squared. So if it said, for example, 3 PB, we'd put a 3 right there. Okay, so now let's plug in our numbers. KSP, we have KSP. So 1.4 times 10 to the negative 8 is equal to our PB x times 2x, remember, squared. So 1.4 times 10 to the negative 8 is equal to x times 4x squared. Which is then equal to 4x cubed. So now we could solve. So when we divide by 4, let's see what we get. We get 3.5 times 10 to the negative 9 is equal to x cubed. And then to solve for that, we take the cube root of both sides. That means x equals 2. Let's take the cube root. We get 1.52 times 10 to the negative 3. You might think you're done. But remember, they wanted it in grams. And typically when we solve these, we always get the answer in molarity. And molarity is N over V. Or also, let's make it simpler, mole over liters. They wanted it in grams over liters. So we grab this right here, 1.52 times 10 to the negative 3. Let's say mole per liter. And we got to multiply by the molar mass of PbI2, which I calculated right here. Of course, you could calculate it using a periodic table. 461.01. 461.01 grams divided by mole. So the moles cross out. And we're left with we get 7.0 times 10 to the negative 1. And that's your answer for how many grams. So grams per liter. Of course, we could just ignore the water because it's already in liters. Thank you.